Hey, what's up, everybody? So this number right here is pronounced 10 to the third power, or 10 cubed. And we call the whole thing a power. You heard me say 10 to the third power. And there's two parts. The 10 is what we call the base. The 3 is what we call the exponent. So let's say I had this number 10 to the fourth power. This is exponential form, and the way it would be written in factored form or expanded form, or you might say expanded form, is 10 times 10 times 10 times 10. So again, this number right here is called the base number, and the 4 is called the exponent. The base number is just repeatedly multiplied, and it's multiplied 4 times here because that's what the exponent tells us to do. In standard form, you might have to calculate this like 10 times 10 is 100, times 10 is 1,000, times another 10 is 10,000. The shortcut, though, is just to look at the amount of zeros. You'll get to know this as a pattern. There's 4 zeros right here in our solution, and there's 4 zeros right here when you multiply. So again, this is called standard form. It's just the normal way to write a number. Let's look at another one. So 10 to the third, that would be 10 times 10 times 10. And again, there's 3 zeros in the factors, so there's going to be 3 zeros over here. It's nice to use 10 to sort of play around with the rules here because 10 is a quick number to multiply. We have 10 squared, or 10 to the second power, and that would just be 10 times 10, which hopefully we already know is 100. And then this is a little bit tricky, but 10 to the first power, since your exponent is 1, you're not really using it as a factor. You only have one factor here, and a factor is only as good as what it's multiplied by. So if this is just one factor, your solution is 10 when you write it in standard form. Now, it does get a little bit more difficult as we go down the exponents here. You can tell I'm going to go to 10 to the 0 next based on the pattern, but what would that be in expanded form? Well, if you're looking at this pattern, something is emerging here. What do you notice? There's actually one less zero in each number in standard form, so hopefully you recognize that this right here could be 1. And the reason that there's one less zero is that you're dividing by 10 every time as you go down. And of course, to get from 100 to 10, you divide by 10. So if I'm right here, we're going to keep with our pattern. Even though it says 10 to the 0, you're probably tempted to write 0 right here. You're going to just keep dividing by 10. Keep with the pattern that was already established. Now, another way of looking at this is the exponent tells us to repeatedly multiply. So if we're multiplying by 1 less 10, it would make sense that we're going to divide our previous solution by 10. Now, if we keep with that theme of dividing by 10, what's 1 divided by 10? Well, you can just express that as a fraction, 1 divided by 10. You could also write it as a decimal 0.1, which is called 0 and 1/10. And if we do 1/10 divided into 10 pieces, think about a dime. A dime is worth 1/10 of a dollar. So if we divide a dime into 10 pieces, you'll get 1/100th of a dollar, or a penny. And hopefully, again, you can collect a pattern right here. This is going to be 10 on the bottom and then 100 on the bottom. So this next number will be 1,000 on the bottom. So we get 1/10 times 1/10, and that's because of the fact that you're really multiplying two groups of 1/10. And you can think of these as negative exponents. If we're going to call positive exponents how many times you repeatedly multiply, think of this as how many times you repeatedly divide. And I'm thinking of this right here as being like a division symbol, the fraction. And then 10 to the negative fourth would just be 1/10 times 1/10 times 1/10 times 1/10. Now, something I do want to point out to you that's really cool, pretty interesting, is if you look at this number right here, 10,000, that was with 10 to the fourth. If you look at 10 to the negative fourth, it's reciprocal. Reciprocal is when a fraction is flipped over, right? So 1 over 10,000 is the same thing as almost 10 to the fourth, except it's flipped over. So you don't see it, but this could be written as 10,000 over 1. And it's the same thing if you look throughout here. These numbers are all reciprocals of each other. 10 to the third is 1,000. 10 to the negative third is 1 over 1,000. Just a pretty cool pattern and something to help you keep track of these. So if we were to do these problems just from scratch, what I want you to know is the rule here, hopefully you've caught it, is that negative exponents create fractions. They create, you're repeatedly dividing instead of repeatedly multiplying. So we know already, hopefully, that 3 to the second is 3 times 3. And 3 times 3, of course, is 9. So if you had 3 to the negative second power, it's going to be, instead of 9, 1/9, since we talked about earlier that a reciprocal is just when the numerator and denominator switch. And my denominator, in case you didn't believe me, is 1 on the whole number 9. For example, b, since it's a negative exponent, it's like multiplying 6 times 6 times 6, except now it's 1/6 times 1/6 times 1/6. And you might be cringing in your seat, right? What's 1 times 1 times 1? This is going to equal 1. You just multiply numerator times numerator times numerator. And then the denominators, we might have to do some calculation here. I know 6 times 6 is 36. And then times the extra 6. Let's see, this will be 36. Carry the 3. 3 times 6 is 18 plus 3. That's 216. So we get 1 over 216. 4 to the negative fourth, this will be 1/4 times 1/4 times 1/4 times 1/4 again. And for this one, I know 1/4 times 1/4, just these two, is going to equal 1/16. And same with these two right here, that'll equal 1/16. So if I just multiply that, let's see, the numerator is still going to be 1. 16 times 16 is 256. I happen to have that memorized because I'm crazy like that. But 16 times 16, you'd probably want to do that out and get yourself 256 that way. Finally, letter D is a little bit harder because there's a negative base. But let's just think about this. If it's a negative base, that means the number you're multiplying by is going to be negative every single time. And it's going to be a fraction because it's a negative exponent. Remember, negative exponents just create fractions. They don't create negative numbers. The negative number will be created if there is a negative base, and that negative base has got a negative, or I'm sorry, not a negative, but an odd exponent. And I'll tell you more about what I mean with that. So negative a half times negative a half times negative a half. Now, hopefully we already know, I'm just going to put a parenthesis around here. Hopefully you already know that a negative times a negative is a positive. So negative a half times negative a half is going to be positive 1/4. And then you still have one more negative half to multiply by. And since we have a positive times a negative now, this is actually going to equal a negative. And so we end up with negative 1/8. So what I said earlier is if we have an odd exponent, I know that the answer is going to be negative because you're going to end up, after multiplying the even amount of exponents, you end up with a positive, right? We had 2 negatives here, so that equaled a positive. But then you still have one more factor to multiply by, and that one more factor has to be negative, whereas this factor has to be positive, so therefore the final solution here, the standard form, has to be a negative. Hopefully this helps you with figuring out if you have a negative exponent, what to do when you get to standard form.